Aston Martin may have just solved the problem that could have destroyed its entire Honda partnership before the new era even began. For months, one hidden issue threatened everything, not power, not speed, vibrations. The kind of vibrations that can damage components, destroy reliability, and turn a promising engine into a nightmare before the car even reaches the grid. But now, Honda is reportedly making progress on a solution, and if the problem has truly been fixed, Aston Martin may have unlocked something far more valuable than a headline horsepower figure. Because a smoother power unit does not only survive longer, it allows the car to run harder, gives the driver more confidence, and lets the engineers chase performance without constantly protecting fragile parts. There is still one critical detail nobody can ignore. The available information does not reveal exactly how Honda solved the problem, or how complete that solution really is. And that missing answer could decide whether Aston Martin enters Formula One's new era as a genuine threat, or discovers that the vibrations were only the first warning. Subscribe to the channel. To understand why this vibration problem matters, you have to look beyond the word itself. A vibration can sound minor, almost harmless. Every engine vibrates, every racing car shakes. Formula One machines are violent by nature, and drivers feel constant movement through the steering wheel, the seat, and the pedals. But uncontrolled vibration is different. It is not simply the car moving. It is energy traveling through the power unit and into components that were never designed to absorb it for lap after lap. Imagine holding an electric toothbrush against a glass table. For a few seconds, nothing happens. Leave it there long enough and objects begin moving. Screws loosen. Small weaknesses become larger. Eventually, something can fail. Inside a Formula One car, the stakes are far higher. The engine, electrical systems, gearbox, cooling equipment, and rear suspension are packed into an incredibly tight space. There is almost no room for unnecessary movement. Every component must remain stable while dealing with extreme heat, enormous forces, and repeated changes in speed. That is why the reported progress from Honda could be so important for Aston Martin. The available source material does not explain exactly where the vibration began. It does not identify a specific component, provide measurements, or describe the solution in technical detail. So the precise cause remains unclear. But the consequence is easy to understand. When unwanted vibration appears in a power unit, engineers cannot simply ignore it and continue chasing more performance. They have to investigate. They have to determine whether the movement is damaging nearby parts, disturbing electrical connections, affecting reliability, or limiting how aggressively the engine can operate. And that investigation can slow everything down. Because every hour spent protecting the engine is an hour that cannot be spent making it faster. This is the first major reason the reported fix matters. Honda may not have simply removed an annoying problem. It may have removed a barrier that was preventing the entire project from moving forward. That changes the pressure inside Aston Martin immediately. Before the vibration issue was reportedly addressed, every performance decision could have carried an uncomfortable question. Can the power unit handle this? Can it run at this level for an entire race? Will a small increase in output create a much larger reliability problem? Those questions force engineers to be cautious. And caution in Formula One can quietly destroy performance. Not because being careful is wrong, because the fastest teams are constantly working near the limit. They are searching for tiny gains in areas where the car is already under enormous stress. If Aston Martin and Honda had to operate below that limit because of vibration concerns, then the engine's true potential could remain hidden. But here is where the story becomes more interesting. Fixing vibration is not always about making the engine quieter or smoother. It can be about changing how different parts work together. Inside a modern power unit, many components rotate at extraordinary speed. Their movements must remain balanced and precisely controlled. Think of a washing machine during its fastest spin. When the clothes are spread evenly, the machine works smoothly. When everything falls to one side, the entire machine begins shaking. The motor may still be powerful, the drum may still be turning quickly, but that imbalance creates stress throughout the structure. A Formula One power unit is far more complex, but the basic danger is similar. Even a small imbalance can create repeated forces. Those forces can travel. They can reach mounts, connections, pipes, sensors, and surrounding structures. And because the car repeats the same actions thousands of times during a race, a small issue can become a serious one. This is why engineers care so deeply about frequencies. A frequency is simply how often something vibrates. Most people have seen what happens when a sound makes a window buzz. The window is not being struck directly. The sound is simply reaching a frequency that makes the glass respond. Now imagine that effect inside one of the most tightly engineered cars ever built. If the engine creates a vibration that matches the natural response of another component, the movement can become stronger. The original vibration may be small. The reaction may not be. That is the hidden danger. And it explains why a solution could involve much more than changing one part. Honda may have needed to study how the power unit behaves across different engine speeds, loads, temperatures, and energy settings. A problem might appear only during hard acceleration. It might emerge at a particular point on the engine's operating range. It might become worse when electrical power is deployed, or it might only show itself after the components become hot. The source does not tell us which of these possibilities applies, but it does show why solving the issue would require careful work, not a simple adjustment. This is also where Aston Martin becomes directly involved. The engine does not sit alone on a test bench during a race. It becomes part of the car's structure. Its mounting points, surrounding bodywork, cooling layout, and connection to the gearbox can all influence how vibration moves through the machine. That means Honda could produce a power unit that behaves perfectly in isolation, yet still discover new problems once it is installed in the complete car. And that possibility raises the stakes. Because a laboratory solution is only the first step. The real proof comes when the engine is connected to everything else. When the car runs over curbs. When the driver changes gear under full acceleration. When the rear tires lose and regain grip. When the power unit heats up, cools down, and then heats up again. That is when small weaknesses reveal themselves. So, when reports suggest Honda has finally addressed the vibrations, Aston Martin may feel relief. But relief is not the same as certainty. The team still needs to know whether the solution works under realistic conditions. It needs to know whether the vibration has disappeared completely, been reduced to a safe level, or simply moved into another part of the operating range. That distinction matters. Because engineers can sometimes solve one problem and accidentally create another. Stronger mounting point may reduce movement in one area but transfer more force somewhere else. A change to one rotating component may improve balance but affect weight, efficiency, or packaging. A revised engine setting may control vibration but reduce performance. This is the trade-off hidden beneath the headline. Honda does not only need to stop the shaking, it needs to stop it without sacrificing the speed Aston Martin expects. And that is where the emotional pressure becomes real. Aston Martin has committed its future to this partnership. Honda is not simply supplying another component. The power unit is one of the foundations of the entire project. The car must be designed around it. The cooling system must support it. The aerodynamics must accommodate it. The gearbox and rear suspension must connect to it. If the engine develops a serious limitation, the consequences can spread through the whole car. But if that limitation has genuinely been removed, the effect can spread in the opposite direction. The designers can work with greater confidence. The engineers can explore more aggressive settings. The reliability team can focus on new risks instead of one recurring concern. And the driver may receive a car that feels more consistent under acceleration. That last point is especially important. Drivers do not experience an engine as a set of numbers. They feel it. They feel how the power arrives. They feel whether the rear of the car remains calm. They feel whether the response changes from one lap to the next. A smoother, more predictable power unit can help the driver trust the car earlier in a corner. That trust may encourage the driver to press the accelerator sooner. And pressing the accelerator sooner can create speed all the way down the following straight. The game begins in one moment. Its effect continues for several seconds. But the biggest consequence may have nothing to do with a single corner. It may change how Aston Martin develops the entire car. Because once a major reliability concern begins to fade, engineers stop asking how to survive. They start asking how far they can push. And that is the question Honda's reported breakthrough may have finally placed on the table. But removing the vibration is only the beginning. Because the moment Honda proves the power unit can operate smoothly, Aston Martin faces a completely different kind of problem. Expectation. A hidden technical weakness creates fear inside a project. A reported solution creates pressure outside it. Suddenly, every decision is judged differently. If the engine remains reliable, people will ask how much performance Honda can release. If the car accelerates strongly, people will ask whether Aston Martin can fight at the front. And if the first results fail to match the excitement, the same story that created hope can become a source of doubt. That is why the next stage matters more than the original issue. Honda now has to prove that the reported improvement survives outside controlled testing. The available source does not provide test results, technical measurements, or statements explaining how completely the vibrations have been addressed. It also does not confirm how the power unit behaves when connected to Aston Martin's full car. So there is still a major gap between progress and proof. And Formula One is brutal inside that gap. On a test bench, engineers can control temperature, load, and operating conditions. They can repeat the same process, study the data, and stop the test the moment something looks wrong. A race car offers no such comfort. The engine must work while the car strikes curbs, changes direction, climbs through gears, brakes violently, and follows another car through disturbed air. Everything moves. Everything heats up. Everything is under pressure. A solution that looks perfect in one environment can behave differently when the complete machine starts fighting the track. This is where Aston Martin's reaction becomes crucial. The team cannot simply accept that the problem has disappeared. It must challenge the solution. It must place the power unit under stress, search for the exact conditions that caused concern, and discover whether any weakness remains. That may sound negative, but it is how confidence is built. In Formula One, trust does not come from avoiding failure. It comes from trying to cause failure before a race does it for you. Imagine buying a waterproof jacket. You would not prove it works by wearing it on a dry afternoon. You would stand in heavy rain and wait to see whether any water gets through. Aston Martin must do the same thing with this power unit. Not with water, but with heat, load, vibration, and repeated stress. The engineers need to know what happens at maximum demand. They need to know what happens after many laps. They need to know whether the engine remains stable when the electrical system is delivering energy, when the car is accelerating out of a slow corner, and when every component is operating close to its limit. Because the most dangerous technical problems are often not the ones that fail immediately. They are the ones that slowly weaken something. One lap looks normal, then another, then another. Nothing appears wrong until a small crack, loose connection, or stressed component finally reaches the point where it cannot continue. That is why vibration can be so difficult to manage. The damage may begin long before the failure becomes visible. Honda's reported progress could therefore change how Aston Martin approaches reliability testing. Instead of treating the power unit as a system that must be protected, the team can begin treating it as a system that must be challenged. That change in mindset is enormous. Perception asks, how safely can we run? Development asks, how much more can we unlock? And once engineers begin asking the second question, the entire project starts moving faster. But there is another layer. A smoother engine can affect the car in ways that may never appear in a headline. Sensors can produce cleaner information. Connections may face less repeated stress. Mounting points may remain more stable.